Hello everyone, my name is Ahmed Alatar and I'm a roboticist. I'll be presenting to you today about quaternions. This presentation is brought to you by We Always Learn, which is an Emirati initiative that aims to spread knowledge throughout the world. Quaternions are an extension to the complex number system that we are used to. They can be thought of as mathematical objects that lie on a four-dimensional hypersphere. Quaternions were discovered by the Irish mathematician Sir William Hamilton around 1843. He discovered this solution as he was walking through or over Broom Bridge. After his discovery, he carved the basic rules of multiplication onto the bridge, after which a plaque was placed in honor of his discovery. So what are quaternions used for? They are used to represent rotations of rigid objects. This representation does not suffer from gimbal lock, which is known for Euler angles, and requires far less computation versus using rotation matrices. They also do not suffer from discontinuities that you would get every full rotation. Any quaternion can be written as a sum of a scalar value and a vector. So a plus bi plus cj plus dk, where I, j, k point in the x, y, z directions. They also hold this property. I square equals j square equals k square, which is equal to -1. So quaternions can be thought of a 4-tuple made up of 4 numbers. Addition and subtraction of two quaternions are done element-wise. So you add the first two scalars and then the corresponding vector values. A scalar product of a quaternion is also element-wise. The multiplication of two quaternions is more tricky and is found as follows. The conjugation of a quaternion can be thought of leaving the scalar part as it is and conjugating the complex part, so by taking the negative of the vector part. If you have a quaternion that represents some rotation, the conjugate of that quaternion can be thought as taking the other direction of the rotation, so the inverse direction. So if Q represents a rotation around the z-axis by 20 degrees, the conjugate of Q would represent a rotation around the z-axis by -20 degrees. The norm of the quaternion can be found as the square root of the quaternion multiplied by its conjugate, or by taking the square root and the sum of the squares. So if we have a norm of 1, that would be a unit quaternion. The inverse of a quaternion can be found as the conjugate of the quaternion divided by its norm. In the case of a unit quaternion, where the norm is equivalent to 1, the inverse of a quaternion is simply the conjugate of the quaternion. Now, how do we use these quaternions? Let's say we have a rotation represented by a quaternion q, and we have a vector v that we wish to rotate using q. If the vector is comprised of values x, y, z, we can write this vector as a quaternion with the scalar part being 0. Then we can sandwich this quaternion with the rotation that we want, so q and q inverse on the other side. Multiplying these out would give us the rotated quaternion. The scalar value would always be 0. We can then extract out the values BCD, which is the rotated vector. If we had multiple successive rotations, we can combine these quaternions by simply multiplying them. Here, q prime would represent a rotation by q1 and then q2. Raising a quaternion to the power n simply means having that rotation n times. So if quaternion q represents a rotation of 20 degrees about the z-axis, quaternion q to the power n represents a rotation around the z-axis 20 degrees times n degrees. And finally, if we wanted to interpolate between two quaternions q1 and q2 and find an intermediate quaternion between the two, which is parameterized by the value t, we can use this slurp. So it's spherical linear interpolation. And by adjusting the value t, you can get an intermediate quaternion or an interpolation between q1 and q2. If t was 0, you would simply get q1, and if t was 1, you would get q2. Any value between 0 and 1 will give you a quaternion in between the two. If you found quaternions to be interesting, then check out dual quaternions, which are an extension to 8 dimensions. So if you would like to watch a video about dual quaternions, make sure to write that in the comments below. Thank you very much for watching.